Welcome to Mathematical Society. Today we will start the lecturing of class XI CBSE medium of mathematics. So many of the students want to know about the whole class, whole topics they want to cover, and we'll cover all the topics of class XI, that means year 11 of CBSE medium. So that those have the your syllabus. So we'll cover all the syllabus in this whole class. Okay. So student who needs to it, so they can view this video. So that will be more helpful for him. And without any payment, you just follow the videos, watch the whole content, and according to that you can increase your ability to solve the problems of your class. Okay, so today what is our topic? Our topic is to introductions to sets. So first let us come to the what is a set. What can you say about a set? Okay, so in German mathematicians, that is your George Cantor, in 1845 that born as, and he is died in 1918. So George Cantor, who is a German mathematician, they derived the concept of sets. Okay, so when he solve his books working on a problem like problems on trigonometric series. When he working on trigonometric series, they he evolved one of the concept that is called set. So he derived the concept set when he doing the solve the problems of trigonometric series. Okay, so if I say you, so a Indian cricket team, Indian cricket team, what you have general think, is it make of a set? When you generally talk about a set, we'll talk about a set of cup of glass. Okay, a set of cup of glass, or a set of cup of chair, a set of chairs, right? So this type of chairs, there are four. Okay, so this type of chairs we'll generally talk about. Okay, so these things you generally have a mind in a, it is a set. Generally every people's have mind, yeah, it is a set. We generally talk about the what is a set. We generally use the word set in our home, in our society, or in our friends circles. But what is the meaning of actually set? If you take a bird, okay, suppose you will consider a bird here, okay, and you consider a cup here, you consider a book, or also you consider a tap, that means the pipe tap. Okay, so is this collection of items, these four items, would make a set? So that is a big question. If you take the natural numbers 3, 4, 5, and so on like this, is this made you a set? That is also a question. So what is actually set? Is this a set? Is this set? Is this set? Is this set? What is a set? The proper answer, if I observe here, anything, whatever you will take, that is a set. Definitely it is a set, no doubts. It is also a set. It is also a set. But the question arises, So a set means there must be a common properties between them. Like here you can see that a set of your cup, you can see that the similarity is that all are cup and all are equal size and shape here, right? In this case there are two chairs and this is a collection of chairs where the two chairs are same shape and size. But similarly here at the collection of natural numbers, these are the only natural numbers, that is the common properties. Similarly, when you take these four items, we must have a common property. Yeah, of course every item have a common properties, but that common properties we have to be derived, right? I think you have understood that one. So you must find a common properties between these four items. If you can find out the common properties through which you can differentiate these four items from the others items, then definitely you can say that at that times this is a set. So that means generally a set means any collection of object is a set. Any collection of object, any collection of object is a set in general sense, right? Okay, but mathematically you cannot say it is a, any collection of object is a set, but that means mathematically we need differentiate between the similar type of objects. Okay, so if you take a similar type of objects, then we can derive some different properties between them. Okay, for that reasons and for many other reasons, we need to define a proper way what is a set. So the definition means set. So what is a set? Okay, so if we see that set means it must be a well defined collection of, you can see that it must be a well defined collection of objects. So we can say that it is a set well defined. You can say that it is a well defined, it is a cup, set of cups, it is set of chairs, it is the set of natural numbers. But we have to find out what is the common property between them, because from now we cannot find we can find out that one, but still now since we have to think about what is the common property in them, how and how can I differentiate between them. So for this reasons we have to consider only the similar type of objects in a set. Okay, right? So what is a set? Set is a well defined collection of objects. Okay, so that is a set. But remind that one, suppose that you will take an element 1 2 1 3, and what about 1 2 3? Is these two sets are same? So you can see that 1 here is repeated, it is repeated 2 times, right? But we need only 1 times. Okay, a set is nothing but a collection of elements in a group, right? So it is a group. In between the group you cannot take the 1 items into 2 times, no. So there is no rule here. Okay, so for this reasons we need a set is a well defined collection of distinct elements, right? So a set is a well defined collection of distinct element, right? So it is more precisely, okay, means more particularly, right? Now, so that means a set is a well defined collection of distinct elements, okay. So example, so that the most fundamental example, that is n, okay. N means set of natural numbers, right? So you can see that all the elements are your distinct and well defined. So this set is well defined. So that is your set of natural numbers. Natural number. Okay. Next, that is the most fundamental. Then W. And what is the W? W is whole number. So that is including 0. So that is your whole number, a set of whole number. So you can see that there is an extra element in the whole number. So except this element, only one extra element, that is 0 here. So then set of integers, right? So 0, 1, 2, 3 towards here, and the negative element -1, -2, -3, and so on, okay. So this set also can be written as like 0 plus -1 plus -2 plus -3 and so on. That is integer, okay. Then is q, and what is q? Is your rational number. So rational number always in the form p by q, where p belongs to z and q belongs to n, okay. We can also write that is p by q, where pq both belongs to z and q is not equal to 0. So there are many ways we can write this set of rational numbers. Okay. Now next, that is R, the set of real numbers. So real numbers is always in between -1 to plus infinite. Real numbers, okay. So there is another bigger set of this, that is a complex number. Complex number always in the form x plus iy, where the real part and imaginary part always belongs to R. That is complex number. So we'll discuss more about complex number in the complex number class. So just remember that that is a complex number. For example, you can say that what is a complex number. So that is 1 plus 2y, 1 minus 2y, similar this way. These are the example of complex number. 1 plus iota I, so iota, 1 plus 2 iota, so like this. Next, so then what is an element of a set? Okay, so let suppose that A is an element of the set A. Okay, so the collection of set of an element can be represented in between the brackets, this curly brackets, okay. So you can represent the set of collection of objects in here, okay. So if A is an element of A, then represent A belongs to A. Okay, that means A is inside in A, right? So A is nothing but collection of elements A or something. So A is inside in A, so you can write that A belongs to A, means A must be inside in A. That is it. So now, how to represent a set? So methods of representing of a set. Number 1, roster or tabular form. Number 2, set builder form. So set builder form. So what is a roster and tabular form? Roster and tabular form means you must represent the elements in listing way. Okay, so let us suppose that A be a set, and I define A be the collection of, so it is the collection of natural numbers divisible by 3 by 3. Okay, so those numbers which are divisible by 3 is inside those natural numbers only, which are divisible by 3 is inside the set. That means is 1 can be inside this set? No, 1 is not divisible by 3. Is 2 is inside in set? No, 2 cannot be divisible by 3. Is 3 is inside inside the set A? Yes, because 3 is divisible by 3. 4 no, 5 no, 6 yes, 7 no, 8 no, 9 yes. So that means if you add 3 by 3, 9 plus 3, that is 12, 12 plus 3 is 15, and so on, you can find this type of items. Okay, so these are the element in listing. So whenever you listing all those items, and we have to given the dot 3 times, so because it will be go infinite times, so there is no ending here. So this type of collection of elements in a set, and this type of set is called in tabular form or the roster form, right? So let us represent the same thing in set builder form. Same set, let us look out in set builder form. Okay, so we have to represent your common elements or these any elements of this set in some specific properties that will held by only this element of the set. Okay, no one other element of the outside this set will have that property. So what is the common property? So x belongs to R, n natural number such that 3 divides n, 3 divide x. Okay, so that means x is divisible by 3. So those elements which are divisible by 3 is inside those natural numbers which are divisible by 3 is inside the set A. So that is called set builder form. Okay, so that means we can represent any set of between the two forms, that is a roster form and set builder form, right? Yeah. So let us suppose that you consider your question. Number 1, write the set X such that X is a positive integer and x square is less than 40 in the roster form. Okay, answer. So you have to write this set in roster form, because you can see that. So this form already in the set builder form, because there is a property. You have defined this element, those elements of your natural numbers which will satisfy this property while inside this set. Okay, so whatever be the set, we will take that set. So let A would be given, that is X, such that X is a positive integer and x square would be less than 40. That means what are the elements of this set? So x square is less than 40. So you can see that x square is less than 40. What is that mean? That means x is less than square root of 40. And what is square root of 40? It's around. Yes. So what is square root of 40? That is 6 point something, right? So it is your less than 7. That means, okay, it is less than 7. So that means those which are positive integer, that is 1, 2, 3, 4, 5 and 6, because 7 square is 49, it is bigger than 40. 6 square is 36, so that means it is less than 40. Okay, so which is in roster form, you can see that we'll listing all those elements in your roster form, right? Yes. So that means any set you can represent in your form. So some question for your homework for today class, you have question number 2. So write in set builder form that is 5, 25, 125, 625. Number 2, 1, 4, 9 up to 100. Question number 3. Write in tabular form or roster form. Number 1, x such that x is an integer and minus 1 by 2 less than x less than 9 by 2. X such that x is a month of a year not having 31 days. Okay, so you write all this month which is less than 31 days. These are included in this set. So you will think about these problems, and in the next lecture of the set, that means your lecture number 02, we'll discuss more about your sets, that is your union of sets, intersection between the sets, complement of sets, and its examples, and what are the properties between these sets. Okay, so stay tuned with this channel, and never forget to subscribe this channel. So I hope this lecture is helpful for you. Jai Hind.